Okay, in this video we're going to talk about scope. This is sometimes the hardest thing for people to grasp and get a handle on, so I'm going to try and explain this as best I possibly can here. So scope, it refers to like the visual version of scope, meaning how variables are visible to other parts of your code. One way to explain that real quick is what we were just doing in our previous version. So if I just ran polycube right here, in my line right here, it would say polycube is not defined, and that's because it's not defined in this scope. It is defined, however, in MC, which is my commands, and I can call it called mc.polycube. It doesn't exist in the current namespace of your main interpreter right here, your main command line right here, but it does exist in MC. So if I said mc.polycube and I didn't want to run it, I just did this, it would tell me that it's a built-in method of the polycube object inside of MC right here. So we understand how this works in terms of a module, that modules have commands in them, and I explained earlier they're like scrolls with magic spells in them, etc. So let's talk about some other scope rules here that I think are useful. We'll talk about the rules real quick. I'll give you a brief demonstration, then we'll actually look at some code here. So here are the scope rules in general. Scope refers to your namespace, and where the variable is assigned, like polycube is assigned inside MC or my commands, determines its namespace or its scope, where it can be found, where it can be seen. Functions, however, add an entirely extra namespace layer to your code, okay? And we're going to talk about that more here, and we actually saw that in the last one with closure, and I'll demonstrate this in a second. Variables defined in a function cannot be used outside of that function. So once the function creates a namespace, I can't peer into that namespace to get a function, or I can't get that variable unless I refer to it by the function value. And the names used inside a function don't collide with other name functions. So remember when we did this right here, we had two versions of cube and x. Let's talk about how when we're scoping, what the scope rules are looking at. So there is a thing called LEGB, and what this tells you is that first the value will look locally inside of its function, and then if it's enclosed, as like if it's a closure, it'll look inside the enclosing function for a variable, and then it'll look in the global and then the built-in. And the ones above that refer to module type namespacing, okay, which we're kind of familiar with already. So let's go ahead and take an example, x for example. So when the local function x, when this local function that we looked at here earlier, let's take a look at this function right here, x. So x is available inside this enclosed function. It didn't find it inside of this function. So there was no x defined inside of this namespace right here in the nested namespace. There was no x. So what it did is it went looking for it in the next level. Okay, so if we go to LEG here and we turn on x, we see x was not found here, so it looked for it in the next function and it found it, so it was good. The first place it finds a variable, it's happy with it and it will use it. It will use that variable. Okay, so x was found here. What about the version of cube? Well, it turns out cube actually did exist inside of the local function, so it was fine there. But then enclosed function needed a version of cube too, right? So let's go ahead and look at that function real quick. Let me just update this here. And when we're looking at this right here, okay, so you'll see that there's a version of cube here and there's a version of cube here. Cube stack cannot go in to make a cube. You can't go down in functions, okay? So this very first rule, whoops, let's go here. This very first rule, when I'm looking for cube, I can't go down into local and get that cube. Local can go up and out and look for variables, but I can't go down into functions and look for that, right? So, but I didn't need to because it had its own version of cube here as I assigned it based on the results from this function. So these two cubes, they're completely different variables, but they're both referring to the same thing, but they don't collide in names, okay? So in the next example, we're actually going to type some code and start doing some printing just to see what we can get out of these functions. Okay, I just cleared out the cube stack and everything, and we're just going to start right here. So let's start right away. I'm just going to say variable a is equal to 10. We'll just start there. Okay, just set a variable like that. Let's create a function after that. We'll just call that sum function. Doesn't matter. And we'll pass in variable x. Okay. And inside there, we're going to create a new variable inside here. We're going to call it variable b. And variable b is equal to the variable that gets passed in times 2. Okay, and we'll print that. Print var, do this, var b, and we'll give it a value. And it's var b, but it has to be turned into a string. So we'll cast that really quickly into a string. Just add that little parentheses there. Okay. And in here, we've done this in the last video, we're going to create another enclosed function. So we'll create def enclosed function. And we don't need to give it any variables. We'll call var c in here is equal to var b plus var a. Okay. Print var c. We're just going to print the version of variable c here. We're going to do basically the same thing we did before. So we're just going to take string var c, just put it in here, 2 close parens. Okay, and we'll just say enclosed function. We'll actually just call it. Wow, can't type tonight. Okay, so this is where we're going to start right now. So I'm just going to highlight all of these things. And I'm just going to run sum function, and I'm going to pass in a value. So I think I'll pass in the number 3 here. So sum function, value 3. I highlight this and I run it. Okay. So as 3 goes in, 3 gets assigned to variable x. So now this is internal. This will just be inside of here. Variable x gets multiplied by 2 and assigned to b. So essentially var x and var b are both being assigned inside of this first function right here. So this is their namespace. This is their scope. Now inside of enclosed function, I'm going to create a new variable called variable c, and I'm going to take the value of b, which I can get because I'm enclosed in there, and variable a, which I can get from way out here. So let's take a look at that real quick here. So we've got this function. This is our code that we just typed, except I typed a 3 in this one here. So inside this function right here, let's talk about that. So we have this namespace, which is the light blue, then a slightly darker blue, and that kind of goes back to this explanation right here. Okay, so we've got the light blue, the dark blue, and then inside here, varc is local, so it finds varc when I go to print it right here. It finds it as the very first one, so it sees it as the L. So it gets to local and it's satisfied for its search. But when it goes to find variable b, it doesn't find variable b inside of the light blue namespace. There's no variable b. So it knows to go to its parent namespace, which is way up here in this function, sum function. There's a value for variable b. Good, we're happy. Let's go ahead and just use that version. So it pulls the version from here, and when it evaluates this version, this is where it gets it. So also, variable a. It doesn't get it in either of these functions. So it searches up here. It doesn't have it locally. It doesn't have it inside the enclosing function, but it does have it globally. And by globally, it's kind of a misnomer. It basically means inside the module you're currently in. And to that end, it's useful to explain that this script editor right here actually behaves like a module. It's just a module called main, and it actually prints back interactively what's going on. Okay, so when I run this, it actually executes the code. So this just behaves like another module. It doesn't behave specially, have anything special. So when you see the LEGB explanation like here, this built in, it actually just behaves like a module. Okay, so let's go back here. So we'll see that variable b gets its value here, and variable a gets its value all the way up inside of the module here. So let's go ahead and just evaluate here and see some of these functions that we can get here. So let's see var b printed, but if I try and evaluate variable b, I get variable b is not defined because it's not in this namespace. Variable a is in this namespace. That namespace that it's in is in this one right here, the very first module. And remember, modules create new namespaces. So if we go back here, we say functions, not modules, I'm sorry, functions. Functions add a new namespace. So your function is the scope of that variable that we just looked at here. So if we go back to Maya here real quick, so we can't see var b, but we know based on its printout that var b was version 6. So when I created this print command, I did have that variable available to me at this print command. So if I printed variable b from in here, I would be able to. But if I had printed c outside of here, so let's actually just put c like after everything here. So let's just print c. Print var, we'll just print the same thing right here. Copy and paste. Let's stop typing so much. Okay, so if I just ran this code right here as a function, and I ran it, I'd get an error. Just because var c is not defined. It doesn't have a var c, and it tells you the global name because it searched all the way up until the top of this namespace right here with the main. And just so you know, that this script editor is actually referred to by name as the main. So if you said underscore underscore name underscore underscore like this, it would refer back to this as main. So every module has a name. So mc.name has a value, mc name. Okay, and that's just called Maya commands. So you can look at any namespace has a name, that's the value. And so the one that you're in right here is just a module called main right here. So it searched all the way up to the global. It couldn't find variable c at all. Okay, but variable c existed here because I was able to print it. Check it out. When we ran it here, we were able to get c. So the scope of c is limited to just inside this function right here. And when you're basically indented into another level, you're at the new level above here. So when you're creating your functions, you have to keep this in mind because it can get quite confusing if you're trying to get a value and you cannot figure out why. You can't figure out why it's not getting the right value. There is a way for you to push these variables up a level or up 2 levels if you need to, okay? And that is by declaring them with the global command. And I don't use this that often because I often find that it collides. If I have some variable up here and I'm trying to troubleshoot, it tends to not. I try to keep things within the scope, the logical scope. I try not to use global, but you know, sometimes I actually do use it. So in order to get C to be visible outside, you would have to declare it right above it, and you say global, and you could say var C, like this. So now if we ran this entire function here, if we like highlighted this, hit enter, and cleared our history, and we ran this line of code, it wouldn't error on us because var C has been pushed up a level. So variable C, even though it's declared in this function, it's pushed it all the way up to the top of the current module. So the module being main right here. Okay, so if I were to highlight variable B, I wouldn't be able to get anything because B is not global. B is just in this function. But if I were to say var C now, it's now the value of 16. And it's available out here in this main namespace. So sometimes you need it to change some value. You can always change a value that's, if I did variable A down here, I could definitely change variable A in here. It would know to change this one because it would search up the name chain and it would change it. Up the namespace sort of stack and change it. So if you do have to make something global, you can do that. There's another one that's available in Python 3 called non-local, but I'm not going to teach it now because Maya does not have it. And there's no way for me to demonstrate it here. So it has to be unique. This is unique to Python 3. So if you're interested in that, there's another one called non-local. And basically what it does is it says instead of moving this variable all the way up to the main right here, it just moves it up to the next function. So it allows it to be seen in its parent function. Okay? So it just moves it up one level instead of all the way to the top of the module. Okay, so that's a lot to grasp for scope. If you have any questions, please ask me. Or if you want some clarification, please ask me. I expect there will be some questions on this coming my way. One thing to keep in mind with this global and how you can get in trouble with it, I'll demonstrate it real quick here. So you've already created a var C, and we've shown that var C is a value right out here globally. It's 16. We've assigned it in here, but what if I took this out now, what if I said, I don't really want to do that? You'll think that that would delete varc, or varc would go away. So if we actually pulled this out like this, recreated a function, and this time we'll run 5 just so the value is different. What you see here is when we print varc, the one on the inside, the first print statement, gives you a 20, which is what you'd expect. But the second one doesn't find the varc that you're looking for, and that's because we declared it globally. It's not in your code, but there is a local version inside of main called varc, and there's a value of 16. And our previous function actually set that value. That value does exist, even though there's no assignment for it now. It's just stuck in memory now for a while because you made a global varc. So when it goes to look for this varc, when it goes to print this varc, it can't go in here. It doesn't see that one, but as it jumps out of this function and gets to the main line here, it says, oh, there is a varc. There is a value that was set previously, and it's 16, so we're going to go ahead and print that. So when you do varc in the global terms, it's the old value that's there, and it conflicts with the one that's in here. So if you're going to use global, be warned that you can set a value, and as long as you're still in the same session of Maya, it'll still exist, and it might cause you problems, because if you start to run varc again in a scope that's outside of this nested function right here, you'll be getting different values here than you will be out here in the main module area. Okay, that's just a gotcha, something to watch for when you're using global to declare your variables. For now, I would suggest for the rest of this class, until otherwise, when we go into UIs and stuff like that, do not use global. I don't want to see global in any of your code until later on when we are actually creating Qt UIs. Okay? Okay. And at that point, I'll explain why you would want to do that, so you don't have multiple panels of the same type. Let's continue on with scope a little bit here. I want you to open up your My Module file that you have in your scripting directory, and I'd like you to just create a copy of, say, hello2, this one that we did earlier. Copy it, and then we'll just put it down here, and we'll call it say hello4. And what we're going to do here is we're going to create a variable here, and we're going to say global blah, or global example, and then we're going to just create this value called ex, okay? And then we're going to assign it the message. So we're going to say ex is equal to the message. All right, so we've got a global, actually let's call it something else. Let's call it glob var. That makes more sense, so we're checking here, and we'll say glob var is equal to the message. Okay, so we'll save this file, and not as say hello2, we'll call it say hello4 because we don't want it to collide with this say hello. So we'll just call this one, and we'll say we'll name this something like global variable example, because you're going to come back to this later, like 5 years from now, and you'll be like, what is this? Oh, I see. So you want to put comments in there whenever you get a chance. So let's go into our code now. Down here, we'll clear this out. We'll say clear our history. We'll say import my module. Reload my module. My module dot say hello4. We'll just leave it the default. So we'll just run all that code. It runs greetings. Now let's just see what happened. So there should be a global variable called globvar. Let's see if there's globvar in here. Globvar, and no, there isn't. Boom. And that's because global namespaces actually are per module. So if we actually said my module.globvar, control copy that here, and we say dot, there would now be a value at the top of the module. So what happened is it stayed in this module, and it promoted this variable globvar from the function up to the namespace. So it would be the same as saying this globvar here. So if we just put globvar here, like globvar, global var, like if we had the variable here and we called it whatever, 5 or whatever, right? Or greetings, whatever. It's the same. It gets promoted. But one thing to keep in mind is that when you're actually doing this here, the LEGB explanation here is the first global is just a module. So whenever you declare a variable as global, it'll only go up to the module that it is in. Okay, it won't pop out and go to the next level. It won't do that. You can easily set it to that. You can create another version. So you can say globvar here in this namespace is equal to the exact same value as my module globvar. So now you actually have a copy here, which is a copy of this version right here. So let's run say hello, and we'll give it a new greeting. We'll call it blah. We'll say not greetings, but we'll say hello, howdy. I like howdy. So let's run this again. Okay, so let's check the value of my module globvar. We'll see that value there. That's howdy. Let's see the value of the globvar in this namespace. Well, we've already assigned it, so we've already done it once, so it's not going to get the value. So we have a variable in here called globvar in the main namespace. We have one inside of the module called globvar, and we have one inside of your function right here. Okay, so you have to keep track of how this globvar right here. So if you said global, you're promoting it. Just to keep that in mind. We could always just keep everything inside the function inside this namespace that disappears, because we use MSG in all of these functions, message, 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 and none of them collide with each other because of the rules of the scope rules that we have here. So the scope rules are functions used inside, names used inside of a function don't collide with other variable names in other functions. Okay, so just wanted to tack that addendum in this example on. So I reiterate, do not use global while you're working on anything until later. So I'm just going to Control-Shift-K to delete that line, and we can actually just get rid of all say hello for right now. We don't need it. All right, Control-Save. And that's it for scope for now. I'm going to move on to the next topic.